Hello guys, today we are learning about the next part of the equation of a tangent. Okay, so let's move to this part of the problem. Like, find the equation of a tangent at the point -1, 3 on the curve with the equation y equals to x cubed plus 3x squared minus 2x minus 1, right? So for this problem, you can just try to first find the gradient of the point on it, right? So we can set here, like dy over dx equals to, here is for 3x squared, right? 3x squared, and then plus 6x, right? 6x. And then minus 2, right? That is the differentiation for this part. And for the function, we can just put -1, 3 into it, and we can have like for dy over dx as 3 times -1 squared plus 6 times -1 minus 2, right? The function finally can be written as 3 plus -6 minus 2 is for -5, okay? That is for this function, okay? And because the function or the tangent can be written as y equals -5x plus c, so you can just set like for this you can just put into -1, 3 in, right? So we can set that is 3 equals to -5 times -y plus c, right? So then we can set c equals to 5 plus 3 equals to 8, right? That is it. So we can set c equals to 8 for this function. Okay, so we can say, oh, maybe here that's a gradient or the tangent for the total line as y equals to -5x plus 8. Okay, that is it. Sure, okay, we have that, and we can set maybe for this is -5x plus 2, and maybe also like this, find the equation of the tangent where x equals to 2 on the equation. So first we can set that the point is y equals to 2q minus 2 times 2 squared plus 3 times 2 minus 4 is 2, right? So we can set that the point, exactly the gradient is 2, 2, right? And then we can set like just last through y equals to mx plus c. So we can set when x equals to 2, we can say that the gradient m equals to dy over dx. That is for 3x squared minus 4x plus 3. But then put x equals to 2 into it. That is 3 times 2 squared minus 4 times 2 plus 3. So it's 12 minus 8 plus 3. It is 7. Okay, that is the gradient here. So it can be set like y equals to 7x plus c. So also you can put 2 into it. So that is for 2 equals to 14 plus c. So c equals to -12. Okay, that is it. So after we have c equals to -12, okay, so then we can set, maybe here we can just put into it and we can set for that is 7x minus 12 is our exactly tangent function. Okay, so here it is. And also here's another exercise you can just try on yourself. Like here, find the tangent to the curve y equals to x2 minus 2x squared plus x minus 3, and at the point 2, 91, right? So just trying to put into it, and like dy over dx equals to the gradient m, right? It equals to 3x squared. It equals to 3x squared times or minus the 4x, right? Minus 4x plus 1, right? That is for this function. So then we can put x equals to 2 into it. So that is dy over dx is equals to 3 times 2 squared minus 4 times 2 plus 1, right? So that the equation here is 12 minus 8 plus 1 is equals to 5, right? So gradient here is 5, right? Okay, that is it. So we have here for the function is y equals to 5x plus c. It also passing through the point 2, -1, so you can just put into it. So it's -1 equals to 5 times 2 plus c. So c here equals to -11, right? Okay, that is the equation here. So we can say here for the equation is y equals to 5x minus 11. Okay, that is for tangent here. Okay, sure. And for another exercise, also for this problem, you can set first trying to calculate the differentiation m equals to dy over dx. That can be calculated as 3x squared minus 6x and minus 11, right? And then just put x equals to -1 into it. So we can say gradient m can be written as 3 times -1 squared and minus 6 times -1 and minus 11. Okay, that is it, right? So we can just set this 3 plus 6 minus 11 equals to -2. Okay, that is it. So gradient is -2. We can say, oh, maybe here for the function is y equals to 2x plus c, right? But still has to find what the c is, right? So we can set here for c, we can just put x equals to -1 into y. So y equals to -1q minus 3 times -1 squared minus 11 times -1 minus 6. That is for -1 minus 3 plus 11 minus 6, it equals to 3 minus 1 is 2, 2 plus 11 is 13, right? So we can say the line passing through the point is -1, 13. Just put into it. That's 13 equals to 2 plus c. The c equals to 11. That is for this function. Okay, so we can set here, if finally the tangent here equals to y equals to -2x plus 11. Okay, that is for this problem. Hope you can truly understand it for all of this. Okay, so see you next time. Bye.